might be one of your favorite chapters. Okay? Now, some of you are wondering the importance of this thing. The importance of this is every time you take a medication, every time something goes into your body and to somebody else's body, kinetics have been done on it. Okay? Have you ever taken a medication that has like a little book that comes with it? Like a little paper? You ever read it? You ever try reading it? Okay, you don't have to understand it, but most of what it says there is about kinetics. Okay? So, what is kinetics? Kinetics is the speed of a reaction. What is the speed on your car, for example?
Miles per hour.
Units on the speed of your car, miles per hour. That means that, how do you calculate the miles per hour? What's the equation for it? It is
Distance over time.
distance divided by time, yes? Does that make sense?
Mm-hmm.
Now, units on this, the speed of a reaction, can it be distance divided by time? Does a reaction run a certain distance? No. What does a reaction have that you guys are used to looking at? It has concentration, yes? Concentration. And then concentration divided by time is the speed of a reaction. So the units for speed of a reaction are molarity divided by seconds. That hints at what the equation is for this. We are going to call this rate. Just like the rate in your car, the rate of a reaction is given in molarity per second. Is this clear? Yes?
Rate?
Rate of a reaction is given in molarity per second are the units of it. Okay? That tells you that more or less what you have to plug in is what? Concentration divided by time. Okay, what we are going to plug in is the concentration of a reactant divided by the change in time. Okay? So let's say we have this equation. And I wanted to find the rate. There's two different rates. Actually, there isn't two different rates, but two different mathematical manipulation of it. How fast does this disappear? This does disappear, yes?
Mm-hmm.
As the reaction goes forward, yes? I mean, you never put this in a reaction, so the reaction goes reverse, right? Most of the time you put two reactants, and what happens to their concentration over time? Decreases as the reaction goes forward to make more C. So these two are decreasing over time, and that is increasing over time, as you are showing it here. On the next chapter, equilibrium, that will change, okay? But this is where we are. How many times does this go away, or does this disappear?
Twice the time.
Two of them, yes? Every time A reacts, two of them go away. Okay, according to this, what is that called? The stoichiometry, yes? Mole ratios. And how many of these go away? Three. Does this disappear as fast as this?
Faster.
No. This disappears faster than this, yes? So, we can calculate a rate based on the disappearance of each of them, or we can calculate a rate that is called the unique rate. And unique means what? Hmm?
That it applies to only one thing.
Only one, right? It's special. One of a kind. Okay. So the unique rate is how many rates? One rate. So in a way, I have to give you a rate in which the disappearance of A is the same number as the disappearance of B. Yes? Because this is disappearing twice. What do I have to do to make this an equal number to that? Let's say I wanted to make this equal to 1. What would I do? Divide by 2. Divide this number by 2. And I have to divide this by what to make it 1?
3.
I have to divide by 3. So what we are going to do is we are going to divide, for this unique rate, we are going to divide by the coefficient.
Lock screen window.
Okay, so the unique rate, we are going to divide by the coefficient. And then we are going to say 1 divided by 2 times the change in concentration of A divided by the change in time. Yes? Because this is the unique rate. All the rates are supposed to be equal to each other because there is only one. So this rate is equal to
1 divided by
1 divided by what?
3.
1 divided by 3, change in concentration of B, divided by the change in time.
Should also be the same with 4 for component C.
Yes. So for component C, that would be 1 divided by 4, change in concentration of C, divided by the change in time. We're not done with this yet, okay? Tell me, what happens to the concentration of A over time?
Decreases.
It goes down, yes? And change means what? Change means final minus initial, yes? So let's say that I started with a concentration here of 1.0 molarity at the beginning. The next concentration should be what type of number? Give me an example.
Smaller number.
Smaller, but give me an example. 0.2? Okay, very good. So 0.2.
It's going to be negative.
So when we do this final minus initial for the concentration, the final is 0.2, yes? Minus initial, which is 1.0. What does that give you? This gives you negative 0.7, yes?
8.
Okay. What did that give you? It gave you a negative concentration. Can we have a negative rate? In physics, we might have velocity that way means positive and velocity this way means negative, yes? In chemistry, is there such a thing? No, because all molecules exist. A negative rate, nobody knows, it doesn't have a physical meaning. So we cannot have a negative rate. So what are we going to do? Since this concentration is dropping and it's becoming negative, what do? We need to make this positive, yes? What are we going to do? Multiply by a minus. And here's another reaction. What are we going to do?
Negative as well. I think the last one's positive.
So you're always right. If it's a reactant, they're negatives. And if it is a product, they are positive. Why is a product positive?
Because it should be increasing.
Because the concentration is increasing over time, yes? Do you expect the rate, as you look at it, do you expect the rate to be a constant number?
No.
Why not?
Because it goes down exponentially or logarithmically. So the rate would change as it goes.
Yeah, but why?
I'm sorry, the last one's increasing because, the last one's positive because it's increasing over time.
Concentration is increasing. Violeta, what's the deal? What do you think of the question I just asked? I saw you daydreaming.
Well,
You weren't sleeping, your eyes were open, unless you sleep with your eyes open.
it makes sense that as the amount of reactant goes down, there's fewer of it, and it's less likely the collisions will happen, so the rate will decrease.
No, but we're talking mathematically. Why is the number different over time? Now, you're right in what you're saying. But here's what happens. The concentration is doing what? The concentration is dropping, yes? As the concentration drops, what happens to this number? Does it get bigger or smaller?
Smaller.
It gets smaller. So what happens to the rate? It gets smaller, yes? Hello? That's math, yes? You guys have a mathematical disability, yes? Apply for the little tag, okay? They'll give it to you. So, the rate is doing what over time?
Changing.
is
Decreasing.
decreasing for what?
For
Is
the
decreasing for reactants, yes?
Mm-hmm.
It is increasing for reactants because their concentration is decreasing over time. A rate, write it down. The rate is not a constant number. Let's talk about the factors that affect the rate, all of which will be on the test. I don't know, you should highlight it. Factors that affect the rate is, well, concentration. The what the concentration, the what the rate. The what?
The lower the concentration, the lower the rate.
The lower the concentration, the lower the rate. But we're not gonna talk about lower, we wanna talk about higher, which is better, yes? So the what, the higher the what? The higher the concentration, the faster the rate, or the higher the rate, okay? So we are going to say that, let's say rate increases with the following. So we can say higher concentration, or we can say increases in concentration, yes? The higher the concentration, the higher or the faster the rate. Now tell me physically, why does that happen? Okay, if you have a molecule here, and the other, this is Opalaka, yes? The other one in Hialeah, how fast are they going to react? Not very fast, yes? Not very fast because
Far away from each other.
it's gonna take a very long time for them to meet, yes? Now, if you have two molecules that are very close together, do you expect them to collide and react with each other? Yes. So the higher the concentration, the higher the probabilities that they are going to meet and collide and have a reaction. So the higher the concentration, the faster the rate. What else? Higher temperature. As you increase the temperature, the molecules are moving faster. And when they collide with each other, they have this amount of energy called energy of activation, which you don't have to know about this yet. Okay? What you have to know is the higher the temperature, the what the rate? The faster the rate. I'm going to tell you, every 10 degrees Celsius, the rate roughly doubles. For every 10 degrees Celsius, the rate roughly doubles. So whatever reaction you have, if you increase the temperature by 10 degrees, what happens to the rate?
10 degrees Celsius, I'm assuming, right?
Yeah, 10 degrees Celsius, yeah.
You say an increase of temperature of 10.
10 degrees Celsius,
Double.
yes? Or 10 Kelvin is the same thing, yes, but 10 Fahrenheit is not the same thing. The rate does what?
Double.
Doubles, okay? Roughly. What else?
Pressure.
The what?
Pressure.
No pressure. Action of a catalyst.
Okay.
What's the definition of a catalyst from your biology class?
Something that speeds up
Something that speeds up
rate
the
of
reaction.
That's it?
That's all I remember.
So temperature is a catalyst?
No, it's the enzyme.
Well, you said it speeds up the reaction, yes?
Enzyme that speeds up the reaction.
Chemical that
Speeds up the reaction without being consumed, okay? Somebody said it. Speeds up the reaction without being consumed, okay? That's the definition of a catalyst. And what also increase the rate of a reaction is an increase in surface area. Guys, do you have the slides for this or no?
No.
My secretary forgot to send it. Alright. Okay? You're gonna have those on the test somehow, okay?
Wait, increasing the surface area of what?
Surface area of the reaction, of the reagents, of the reactants. explain this better, yes? Let's say we have this. We have a sphere, okay, a bowling ball. Is a bowling ball hollow inside? It might be, yes? Is
Would you
it?
like to pick it? It's not heavy.
What?
Nothing.
It's not that heavy?
It depends what size you get.
You're strong, that's why.
Maybe the baby bowling
But
ball.
the initial question is it hollow inside? That's what I wanna know.
Yes. Maybe it has-
Huh?
I don't know.
You never cracked one open?
No.
But you play bowl, you bowl. Good for you. So now you gotta find out. Steal one from the place you go play. Alright, so, okay, let's say it's a solid sphere, okay? Can't be a basketball, it has to be solid from here to here. If I put this solid sphere in a reaction, where is the reaction going to occur only?
Surface.
On the surface of the sphere, yes, on the surface. Because the inside, in order for you to react whatever it's inside, what has to happen first? Has to react with the outside, okay? So some of the pills you take work like that. They have a difficult to digest layer, okay? So it's slow release or time release. It takes a certain amount of time for you to digest the outside, so when you digest a little bit of the outside, then you have more medicine. And then you gotta digest it again, and then more medicine, and like that. Okay? So, but if I get this, and I break it, or I increase the surface area by physically cutting this, then now all of my reaction is going to take place in that little bit, which is supposed to do what to the reaction? Increase the rate, because there is more surface area for the reaction to occur. And of course, this is referring to the reactant. It's not referring to the product. Yes or no?
Okay.
Hello?
Yeah, makes sense.
So if you wanted your food to be digested well on your stomach, because that is a reaction, what would you do?
Cut it.
You would chew it. Yes? Your parents ever tell you, chew the food? No?
Okay.
Parents don't care about you.
Just swallow.
If they never told you, that's because they don't care about you. Now you know.
Only does it now.
You'll be fine.
Alright. There is something called the rate law. So we call this thing that we did here, it was called the unique rate, yes? It was called the unique rate because it had that number or that coefficient in the front. If I do not divide by that coefficient, it's called rate of disappearance or rate of appearance if it's a product. Yes or no? You guys write it down, write it down. If it doesn't have that division by the coefficient, it's called rate of disappearance or rate of appearance. Because it does disappear 2 times, let's say, and the other one disappears how many times? 3 times, right? Without dividing by it, it's not unique. It's called rate of disappearance. Let's get into the juicy stuff, yes? This is called the rate law. Now, the rate law is the same numerical value as the unique rate. So this number is the same. What?
Rate law and unique rate.
No, I didn't say that. I said rate is the same numerical value, different equation. Yes? So how do I calculate the rate? I calculate the rate using the unique rate, yes? Because I can see the concentrations changing. But now here's a different expression, and this expression is called the rate law. But the number is the same, yes? Equation different, number is the same. Some student in the past has asked me, oh, so why do we have 2 different equations for the same number? It's like, what? Why not? Can we have 3? Yeah, we can have 3. It's like saying, why do girls get different hair once in a while? Because they like to change stuff. That's why. You know, one day is blonde, and then the next day is black, and then yellow, green, blue. It's all kinds of things. Nobody asked them. Alright. So here is the rate law, okay? Rate law equal to a constant called rate constant. Rate constant, and the rate constant is called K, right? It's K raised to the rate constant. Multiplied by the reactants. So I'm going to say reactant A raised to a power, which we don't know what that power is, called the M power, and times reactant B raised to the N power, and if it has another reactant raised to another power. Does this have to be M and N? Can this be
No.
X and Y?
Yep.
Yes. There's Z and W. Yeah, so
Whatever.
it could be whatever it is. They are unknowns, and they're called reactant orders. They are called reactant orders. The addition of M plus N is called overall reaction order. Overall reaction order. The orders could be 0, and this is how you say it: 0th order, 1st order, 2nd order, 3rd order. Okay? So these numbers can be 0, 1st order, 2nd order, 3rd order. Okay? Now the ones that we are going to study in this class are 0th order, 1st order, 2nd order. There are other ones which we'll not talk about. Okay? I will prepare you for these 3, and the rest you will figure out when you get to pharmacy school or medical school and you have the same equations again. So when you go to medical school and you're getting your MD, let's say at UM, is it going to be different? Is the professor going to explain it better? Never in his life. He can drink, but it's not going to happen. Okay, so, because you guys are getting an average here that I don't want to disclose to the public. So, M plus N is called overall reaction order, yes? Now, M and N are only found experimentally. So, can you figure them out by looking at the reaction? No. What do you have to do? You have to go to the laboratory, you have to go to the lab and do an experiment and find out what they are. You are going to do that in the lab here. If you're taking the lab with me, that's what we're going to do, I think, today, yes?
Yeah.
You guys bring the lab manual to class?
Mm-hmm.
You brought it? Class hasn't started yet, but. So, we have to find them experimentally. There is another way. We can know the M and N for an elementary step, okay, something I haven't talked about. But we can't get it from looking at a equation if it's an elementary step. It's something you don't have to know, okay, so don't worry about it. As far as you know, M and N are found experimentally, okay? How's that so far?
Good.
It's like another A on the next test, right? So far it is, huh? I gotta make this class harder. They tell me that I gotta fail at least 70% of my class. If not, I'm not doing it right. Who's they? Who is they?
Yeah.
I can't tell you. What were we talking about?
The rate law and then M and N are only found experimentally.
Let's say I find M, and M in that place is equal to what? Okay, if it doesn't have a number up here, it means 1, yes?
Right.
Okay, because if it were 0, it'd have a 0 here. So if it doesn't have anything, it's a 1. So this is first order. The reaction is first order overall. There's only one reactant. So this thing is like decomposing. If this had a 2 here, what would that be? Second order. And if it had a 0 here, what would that be?
0.
0 order. These are powers, yes?
Mm-hmm.
So anything raised to the 0th power is equal to what?
One.
1, yes? So this is like the concentration doesn't matter. Okay? So what about this? What if I have this?
It's the sum of both orders.
It is first order on A, it is first order on B, and what overall? Second order overall. Is there a difference between this second order and this second order? There is. This is called second order homogeneous, which means only reactant is taken into account. And this is second order heterogeneous. When you go to that other school that you might go to, if you can pass my class, you will do it heterogeneous, okay? Unless I have heard from medical school students and even some pharmacy school students, the professor said, nah, let's not do it heterogeneous. Why? I don't know, you gotta ask that professor why he did it that way.
Didn't feel like it.
Because the math gets complicated. Because what we are going to do next is we are going to integrate. Do you know what integrate is?
Mm-hmm.
No.
Integral from calculus. You guys have taken calculus 1 and 2 for this class, yes? You know how many people would be in this class if you needed to take calculus 1 and 2? There would be 2 guys in this class. Alright, look, let's say this. First order, yes? Let's say I double the rate. Double the rate, what happens? I mean, not double the rate. I double the concentration, what happens to the rate? Huh? If you say double the rate, do I need to know what A was at the beginning? If I say double the rate, do I need to know what A was? No. All you need to know is if I double this, there is going to be a what of factor? A factor of 2, yes?
Mm-hmm.
If I multiply a constant by a factor of 2, what happens to the rate?
It's twice as much.
It increases by a factor of
2.
2. So if the rate doubles, write this down. If the rate doubles, when the concentration doubles, if the rate doubles when the concentration doubles, the order is what's the order? Monsieur, Miss Lacey, what's the order?
The order shouldn't change.
When the rate doubles, when the concentration doubles, the order is 2. The order is 1, first order.
Yeah, makes sense.
Okay,
It's not going to change the exponent.
guys, for the mathematical impaired, yes? If the concentration for second order, if the concentration doubles, yes? I double the concentration. What happens to the rate? Really? When the concentration is raised to the second power, the rate is gonna double? This is gonna be an increase of 4.
So quadruples.
So it quadruples.
Yeah.
If the concentration is doubled and the rate quadruples, the order is second order.
You say first, no? Or is another case?
That's another case.
Okay.
Marais, did you get that? So explain it to the class.
That when the rate quadruples.
Go ahead. Quadruples, what? Go ahead. So everyone can know that you understood. You did get here late, didn't you? So, guys, if I double the rate, look, let's do it another way, okay? because you guys seem to have a problem with this. You want me to explain it another way, or is that okay? I don't need to explain another way? So, the rate looks like this. This is the equation, yes? K of A raised to some power. Yes? Let's just do 1. Raised to some power. And how do I find what this power is? I gotta double the concentration, yes? And I have to look at what happens when I do double it. So when I double it there. What has the exponent? The concentration or the rate? Concentration has the exponent. And I don't know what it is. But I double the concentration, and then I look at what happens to the rate. It doesn't, because it is what it is, yes? Let's say that the rate increases by a factor of 4. What is the exponent on that thing?
2.
It is 2. So, if you double the concentration, and you double the concentration all the time to know what you are raising this to. So, if you double the concentration, this M will be 2 if it increases by a factor of 4. Yes or no? Is that better?
Yeah.
So let's say that I triple the concentration and it increased by a factor of 9. What is the order?
Second order.
Second.
This concentration, yes? This is what has the exponent. I look at what happened to the rate, and 3 to what power gives me 9? To the second power. It's still second order. Yes? So write this down on your paper. If I triple the concentration, and the rate increases by a factor of 27, what's the order? Don't say it. I want you to write it down.
Doesn't it depend on the number of reactants?
I mean, if they're part of the rate law, yeah. But it's independent. For one reactant, you're only looking at that one reactant. Okay? How much is it?
Third order.
The third order, yes? Third order. Now, third order reactions are difficult because third order reaction means that 3 molecules must collide at the same time with a correct orientation and a minimum amount of energy, okay? So write it down. Third order reactions are unlikely, statistically improbable. So let's say third order reactions are unlikely, okay?
Unlikely.
Yes, statistically improbable. So, so let's say someone asked you, hey, find out the order of this reaction. What would you do in the lab? You do what? Double the concentration, that's right. Why do we use a 2? Why do we double the concentration? Because 2 is a number that most of us know how to multiply it and divide by, yes? It is just because it is easy. Can it be another number?
Yes.
It could be whatever number, okay? So, write this down. I double the concentration, and the rate stays the same. What order is it?
0th order.
And the rate stays the same. What order is it? It's not first order. If it's first order, it has to double the concentration, yes? I double the concentration, double the rate. Double the concentration, rate stays the same. You don't understand what it means for the rate to stay the same. For the rate to stay the same means this, okay? And that's okay. We're going to do numbers on this. Let's say that the rate is this for a certain concentration, yes? Let's say that this concentration is that amount. And let's say that I do what to the concentration?
Double.
I double it. And then I look at the rate, and the rate is the same. Did doubling the concentration have an effect on the rate?
Nope.
No. What it means is that the order on this is 0. Okay? So let's say this is what I have. And I increase it to this.
When would this happen in like a lab settings?
What do you mean when?
Like, I'm just trying to like,
When? Today at 12:30.
not the time frame, like the scenario with what type of,
All types. There is no reaction that does not do this.
okay.
All reactions do this. All of them. Okay, so I gave you numbers there. Tell me what happens. What order is that for those numbers over there? First order? Yeah. You did what to the rate? Double the rate, yes? And this is 2. What do? You get the big number, divide by the little number, yes? So if you get 0.6 divided by 0.3, what does it give you? 2. The concentration is the one that has what on it? The exponent, yes? Let's call it y this time. And then I look at what happened to the rate. It might not be easy numbers, so you divide what you did before, big number by the little number, so you divide 3 by 1.5, what does it give you? Hello? 2. And 2 equals to 2y, y is equal to what? 1, yes? So this is what order? First order.
And the other one? Is 0?
This other one is 0th order. How's that, guys?
Good.
Is that good? It's good?
Mm-hmm.
Calculate the unique rate using the following data. Let's say this is, by the way, did I ever tell you that brackets means concentration?
Mm-hmm. I
Okay,
know.
write it down. Brackets means concentration. So, whenever you see brackets like this, in this class, this means concentration. So, here's the concentration, and here's the time. So let's say time in seconds. The concentration is in molarity, yes? So let's say this concentration is 1.0. And the time is at time 0. And let's say this is 5, and this concentration is 0.8. And this is 10, and this concentration is 0.5. This is 0.3. I want you to find the unique rate from, by the way, if I ask you to find the unique rate, what do you do?
You just take an interval of time.
You need an interval of time, that's right. So I gotta tell you, find the unique rate from 0 to 10 seconds. From 0 to 10 seconds. Guys, you like mangoes?
Oh, yeah.
You like mangoes? Me too. I went to the neighbor's house when he wasn't there to steal his mangoes. And there were mangoes on the floor, and I grabbed them, and they looked like they had just fallen off. So when I take a bite of them,
Oh, man.
and I went to my house and I did it over the sink, yes, it squirts out. They're very juicy. Squirts out stuff. Some of it lands here on my lips and on the sink, everywhere. And I feel some crawling sensation in my face.
Oh, no.
And I go, what the hell?
You got
Look at
nice
this, there are
worms.
worms.
Yeah.
I'm not saying 2 or 3. I'm talking about there were more worms inside of this mango than mango itself. The worms were all over the sink, but they tasted like I swallowed what I had in my mouth. And then I imagined them going like this in my stomach. I killed them with the acid anyway. So they taste like mango, so take home messages, don't pick them up from the floor, okay?
Don't steal it.
Well, I wasn't gonna throw it away. They taste like mango. If you're a guy, you should do it there, right? Just eat the mango, videotape it, right? And all the worms are there, and then eat them. It's awesome.
You remember that show
They
they used
taste
to
good.
put Fear Factor where they ate a bunch of that stuff?
Yeah.
That would be nothing for them. That was crazy.
Well, they had to do it, okay? I don't think they did it for fun.
They ate
Like I was by myself. It's pretty sick if I eat the worms by myself.
bright and early morning breakfast.
If you're with a girl, you want to impress her, then you eat all the worms, right? The girl will be impressed forever. She like, damn, this guy goes for it. Alright. So, we want the what? The unique rate, yes? How do I calculate the unique rate? Give me the equation. Hello? What? You said concentration of A?
Shade times concentration.
1? Oh, 1 over 2. Oh, outstanding. Why is it 1 over 2?
Because it's unique rate.
Because you want the unique rate and this has a coefficient in it, yes? Apparently the tutor already explained this one to you, didn't he?
Yep.
Now this is a reactant, yes? What happens to the concentration over time? It drops. So what am I going to place in front of this? A minus, okay? Anyway, let's say that you made a mistake and you forgot that you had to put a minus. The rate will be what value? Negative. What do you make that after that? You make it positive. The purpose is no rate can be what number? Negative, okay? You make it positive, but don't worry about anything else. Change in concentration of A divided by
Change in time
change in time.
is equal
So
to.
this is equal to minus, let's do it here. So this is equal to minus 1 divided by 2. Change in concentration of A. What's the change in concentration of A? It is final minus initial, yes? Which one is the final here? It is the one that belongs to this time, yes? 10 seconds. Here's 10 seconds. That's 0.5. 0.5 minus initial concentration, which was 1. What does this give you? Minus 0.5, yes? So this is minus 0.5 divided by what? This is molarity. Divided by what? The change in time. And the change in time is, what's the change in time?
10 seconds.
How do you know?
It goes from 0 to 10.
Change in time is final time, which is 10 minus 0. This is just 10 seconds. So I divide by 10 seconds. What does that give you?
I get 2.5 times 10 to the negative 2.
What?
2.5 times 10 to the negative second.
2.5 times 10 to the minus 2 what?
No, molarity per second.
Molarity per second. Very good. Okay. How's that? That's the first question on the next test, okay? Do I have to find what happens to B in order to calculate another unique rate?
The rate group.
No. Do I have to find the concentration of C to calculate the other unique rate? No. I only need to follow what? One concentration, and then when I follow that one concentration, I can calculate the rate for everybody, because this is called the unique rate. Yes or no? Okay? I only need to follow one, whatever it's easier. Let's do something called integrated rate law. An integrated rate law means what? That they are integrated. And this integrated means the integral from time 0 to time t. Now, if you're taking math and you want to know the equations, you come see me after class, okay? Because calculus is not required for this course, right? Yes or no? Not required, so I'm just going to give you the result of that integration, okay? That's what you want anyway. This is in the order in which I like to remember them. First, second, 0, yes? Because 0 comes before first, yes? But first is more important than 0. So it reached 120. Yes? Mm-hmm. What you have to remember for first order is dln. Okay? Now this will be dln of A at time t. So it's called dln of AT. They will all have ATs somewhere. Okay? The first one is just dln of AT. Second one is going to have AT, but it's going to be the reciprocal of AT. So what is it? 1 over AT. And the 0th order is just going to have AT on the top. So, what do you remember for first order integrated rate law? ln. Second order? Reciprocal, 1 over AT. 0th order? Just AT. If you know this, you will more than likely get the rest of it correct. If you make a mistake here, there's no way you're going to get the rest of it correct. They all have an equal sign, and they all have KTs. KT, KT, and KT. Okay? There are signs in front of this, either negative or positive. We're going to start with the negative because we are negative like that. And then they will go from negative, positive, negative, because two negatives next to each other is not a good thing. Is that easy so far?
Yeah.
All of these are going to have plus something. And this plus something will be exactly the same thing you see here, but instead of with a t, which means at time t, it will be time 0, which is called initial. So we're going to say ln of A0. And what am I going to write here? 1 over A0. This is time 0. Integration from time 0, right? But it's called initial. And what am I going to write down here?
A to 0.
A0. How's that? That's cake. I came up with that idea just for you guys, okay? That's how I spend my time. Trying to find out what best. Okay? Now, what some of you are going to try to do on the test is, you do not listen to me, right? You go to another video something, and you will write here ln of AT, and here you will write 1 divided by A0. This is what you're going to do on the test. Or you have this one here, you write ln of A0 here. You will confuse the equations.
Quick question about that problem before you erase it all. just at the end where you were finding the change in concentration, those values you used, I'm just not sure why you did 0.5 minus 1.
Those are the values.
Well, you had
10 seconds.
0.5 concentration molarity, and then you had over 10 seconds.
Yeah.
For 10 seconds. And you started at...
Because I wanted it from time 0 to time 10 seconds.
Okay.
So I have to use the concentration at that time.
Okay.
The concentration at 10 seconds was 0.5, yes? Was it or was it not?
Yes.
If I could change to a time, and won't that rate be inaccurate because you need to get it as close to that point as you can?
It's what?
Since you have that 10-second discrepancy, shouldn't the number that you're getting be inaccurate because you have to get it at exactly that point?
What do you mean exactly at that point?
If the rate of the reaction changes and you want to get it, say, at 10, then you have to get it to be at 10 and not from 0 to 10.
The rate changes with the concentration, yes?
Yes.
So the concentration at that time is a number. And you just use those numbers. It's not inaccurate. Exactly what it is. The rate does change over time. That is inaccurate. It changes over time. So, where did these numbers come from? These numbers came from integrating this over time, yes?
Mhm.
The equation you don't know about, it doesn't matter. Now, this is an equation of what? What is this the equation of? Is it a parabola, hyperbola, line, or what is it?
Has an intercept.
Are you a math tutor at the Wolfson campus? No? What are you?
Just volunteer at the lab, that's all.
Oh, okay. I was gonna put you on the spot. Marai, so what's that equation of? That's not calculus? This is like high school stuff. Okay, guys, look. This is the equation of a very difficult thing, okay? Called a line. Okay? But surprisingly, guess what this is the equation of?
A line.
Another line. And this is the equation of
A line.
another line. Because we are incapable in this class of knowing anything else other than the equation of a line. Because we cannot do things in our head with logarithmic functions, yes? So we like to change things. And I'm going to tell you, a line looks like this. Y is equal to
MX plus B.
mx plus b. This thing here is called the slope, and this is called, oh, you know about this, huh? But you can't tell where you have one, huh? Okay, so ln of AT, that's the y. Yes or no? These are numbers. And tell me, from over there, which one is the slope? K is the slope? Okay, it's not the slope. It's minus K is the slope. What's it minus doing? From the first one, yes? Minus K is the slope. So that's the Y. Minus K is the slope. What's the X?
Time.
T is X plus, what's the Y-intercept? ln of A is 0. So let's build this graph. Here's a graph. What's on the Y-axis? Huh?
Concentration.
I am glad they're not recording this today. What's on the y-axis, guys? Look.
Concentration.
Not concentration. What's on the y-axis?
ln of concentration.
ln of AT. Not concentration. ln of the concentration. What's on the x-axis? Time. The slope is going to be what? Positive or negative? Negative. Yes? Negative, yes or no?
Yeah.
Everyone agrees this is negative because?
Goes down.
Because it has a negative. If it is negative, It looks like this, yes?
No.
No.
That doesn't look like that?
No.
Oh, I made a mistake. Alright, well, I don't know it all, okay? So let's say negative is like this.
Yeah.
Yes, very good. The slope of this line is equal to what? Minus k. That's right. And this is called what?
Concentration times 0.
What is it called?
ln of a.
No.
Y
What
intercept.
is it called?
Y intercept.
Y-intercept. Because here's the y, yes?
Mhm.
And as you can see, it is intercepting the y. This is why it's called y-intercept. So the y-intercept is equal to ln of a0. Okay? How's that?
Super.
It's cake. I'm not gonna lie to you. Let's say that I have this. What was the initial concentration?
0? Doesn't make a lot of sense.
So you're telling us that the
Oh,
y-intercept is negative?
No, it's negative. What? But where's time? Does it mean that it's a 0 order reaction?
I mean, the y-intercept is at a number or no?
Yeah.
Is the y-intercept a number? Yeah, it's a number. They're all numbers, yes? They're all numbers. So that's the y-intercept is equal to a number. So what is the concentration of A0?
Oh, it's the.
I can't have this ln here. I need A0 by itself, yes or no?
Yeah.
How do I get rid of this ln?
On both sides,
What?
do the inverse.
Divide by what?
Like, yeah.
Something with it. It's horrible. I'm telling you, it's horrible. Yes, something with the E, okay? So, if it would have been 10, it's called anti-log. With the E, I have no idea. Okay? But, if I raise E to this power, that drops, yes? Yes or no? So, E to that power, that disappears. If I did it on that side, I have to do E to this power on this side. So that will be E to the minus 0.736. That's the concentration of A0. Whatever number that happens to be. What is it? Whatever, doesn't matter what it is, okay? Yes or no?
What does it do?
0.479 molar. Wait, is it molar? Is it
I don't know, what do you think concentration
It
should be?
makes sense, but since the y-axis is an ln of a instead of just a.
Yeah, but you did E to the X, so the ln dropped out. So it's just concentration. Because when you do the ln of concentration and then you do E to the ln, then the ln disappears, just concentration left. Okay, why don't you do the similar thing here with the graph for the second one? What order is this? First order. How do you know this is first order? Because it says ln. Second is second order, yes? Maybe Marais can come to the board and fill it out. Tommy girl. what do I write here?
1 over A.
That's right, 1 over AT. Very nice. She paid attention. Why do I write 1 over AT for second order? Because the y is this stuff here. Yes? And then, what do I write down here?
Times that.
Times. Very good. How do you know this is a line? Yeah, but when you look at it, how do you know this is a line? If it were raised to a second power somewhere, it's not a line. Correct? So, if it has that form of 1 and then equals to 1, 2, more than likely that would be a line, okay? In this class, you know it's a line because it's always a line. Very good. Okay, so the slope here is positive or negative?
Positive.
So it looks like this, yes?
Yeah.
Yes or no?
Yes.
What the slope here is?
Okay.
Positive k, very good. This y-intercept is 1 over a0. Let's say I know what that y-intercept is. This is what I get. It's non-molarity. That's what I get. What is it equal to the initial concentration?
2.
Is the initial concentration 0.5?
No.
No. Initial concentration is this, yes? 1 is that. Is the initial concentration. This is 1 divided by that. So what do? Find the reciprocal, yes? So it's 1 divided by 0.5. What is it? 2. Okay? So let's say 2.0. And the units are molarity. And on the third, what's the third? Let's say the third graph, what do I write here? 18. What do I write down here? Time. Slope positive or negative?
Negative.
Negative. And the slope is equal to minus k. And the y-intercept is a0. If you had that 0th order, you would not have to do anything if you get the y-intercept. Okay? Can a reaction be first order and second order at the same time? No. Reaction can only be one order, yes? It can either be first, second, or 0th order. So the data is going to fit only one of those equations. Yes or no?
Yep.
If the data fits that equation, it will have that graph in which you will have a line for that data. If it does not fit the data, would it be a line for that graph? No, it would be a curve. So if you have a reaction and you plot ln of AT versus time, and you plot 1 over AT versus time, and you plot 1 over AT versus time, you get 3 different graphs. How many graphs do you expect of those to be linear?
1.
Only 1. The other 2 are not going to be linear. The one that is linear, it belongs to that order. Write that down. Precisely the reaction I want to see. All you guys were looking, and then you went down and you tried writing something that you didn't know what to write down, yes? If you want to find out the order of a reaction, look at which graph is linear. Of course, you have to know which graphs we're talking about, yes?
And you can look at the slope, right? If it's negative, if it's positive. If it's
I mean, yeah, let's say that I don't trick you on that, and I give you the same slope, but if it's not a line, then it won't have a slope.
Okay.
But yeah, you look at the slope to find K.
But how do you know which reactant to look at when you're doing it?
What?
Say for instance that the rate law for a reaction has one of them squared and the other just within a exponent of 1.
Because you're looking at one at a time, yes? We're doing only homogeneous here, meaning we have only one reactant.
So we're not doing any of the others in class?
No. So let's say we have this. And this is the same data. What type of data would I get from a reaction, by the way?
Concentration.
A reaction only gives you concentration and time, yes?
Mm-hmm.
Somebody switched the cell phone to them.
Okay.
What's happening? You don't know how to turn it off?
It wasn't even on, it just, the app opened itself.
Yeah. No, that's what mine did that day, right? That's fine, don't worry, okay? No big deal. So the only thing that you get from a reaction is what? It's the only thing you get from a reaction. Concentration and what else?
Time.
And time. Yes? Concentration and time. How do I get the concentration of a reaction? I follow it, right? It could be color, it could be whatever it is. It could be some type of spectroscopy. It doesn't matter how I get it. But I'm going to have AT. So how do I do this plot? I find the ln of this number, yes?
Mm-hmm.
You know how to find the ln of a number?
You go into a calculator.
Yes, you put it in the calculator. You put the number and hit the button ln, or ln and then the number. And it gives you this number. What if I want to find this one? What do I do?
1 over the number.
1 divided by this. So let's say that this is what I get. I plotted the data and I get those graphs.
Okay.
What order is this?
Second.
Okay, you look at the one that is linear, yes? Only one is supposed to be linear. If 2 of them are linear, there is a mistake somewhere. So here, this is 1 over AT. What order is that? This is second order. So this data fits second order, is linear, so the reaction must be second order. Okay? The reaction is second order. Second order on A, yes? Second order on A. Yes or no?
Yep.
If I graph this, I graph it in a program, yes or no? What type of program would you suggest for graphing?
Excel.
A calculator?
I'll use Excel.
Okay, Excel, I mean, you like Microsoft, okay. It could be Excel, it could be whatever other graphing program you have, yes? You graph it there, and would that program give you the slope of the line? It'll give you the slope of the line. If it gives you the slope on the line, it'll look like this. Y is equal to mx plus b, yes? They'll give you this. Y is equal to a number plus another number. Mx plus another number. From there, you know that the slope will be what? Yeah, the slope will be m, but what will it be? Positive k. Okay, and the y-intercept, which is this number, what would that be? 1 over a0. Yes? And from there, you can find the slope, and you can find the initial concentration. How's that, guys?
So is that what we're going to do in the lab?
Yeah. You're going to find the orders only in the lab. You're not going to do that, no.
So in the test, would you give us a number of values and tell us to plot and see which is which?
No, in the class you won't plot anything. I give you the plot already made. Let's do another 3 equations, yes?
Sure.
Because you guys like equations. let's talk about half-life. Did you say yes?
No, she said yes. I thought it, I just laughed.
Why do you want to know about the half-life?
Why?
Because I recognize
No. Okay, so half-life, what's half-life?
have a life.
It's a video game, yes?
Pretty good
Half-Life
one.
is a video game. If you didn't know, you haven't gotten out much, okay? That's okay.
Or you got not too much.
Well, maybe. So half-life. Half-life, write this down. Half-life is the time it takes for the concentration to drop by half. Half-life is the time it takes for the concentration to drop by 1/2, or to drop half of what it was. Okay, without looking at your notes, tell me what are the units on half-life?
Concentration over time.
What is it? Guys, you don't have to say the right thing, okay? Like when you avoid eye contact with me, it makes me feel bad, okay? Don't make eye contact. I want to look into your soul. So,
I want to go with concentration over time.
okay, all right, that's what he went with. And the rest of you want to go with what? With I don't know? Yeah, read what I said to you.
Half-life.
The time it takes for the concentration to drop by
Wow.
half. So it's already given that it
18
dropped by half.
seconds.
So it's just time. Okay? Could be time in seconds, it could be time in years, could be time in centuries, whatever time you want. But half-life is only units of time. So when you read a half-life somewhere, what is it going to be? Just time. If you have a half-life of a medication you are taking, the half-life is 60 days. On day first, when you take this pill, let's say you take 1 gram of this pill, and the half-life is 60 days. After 60 days, how much of that pill do you have inside still? Half of 1, which is 0.5. And in another 60 days, how much are you going to have? Half of 0.5, which is 0.25. You can see that whatever medication you take with that half-life is going to be inside of you for a long time. Yes? So if you are undergoing surgery, should the half-life of the medication that you are having for surgery be long? It can't be long, because if it's long, you're going to be sleeping forever, yes? So most of the time the half-life is short. So they keep injecting you the medication so you're out, right? And whenever they want to wake you up, they just stop giving it to you. It runs out and then you wake up, right? Right? You guys ever had something done, general anesthesia?
Yeah, it's horrible.
Horrible, you crazy.
No, because they have to. Well, I don't know.
It's the best thing ever. I want to
Because
go.
they give it to you in
general
your spine. It's
anesthesia
like.
again. That's awesome. Dying is not going to be so bad. You're not going to remember what happened.
Oh, cool.
All right. Okay. So there are equations for this half-life too. Okay, let's do. What time is this class over? 9:40. We got 25 minutes. Let's say. What is the concentration of X if the half-life is 12 hours so let's say what is the concentration of X after, let's say, 3 days. So what is the concentration of X after 3 days? Let's say this is, what is the concentration of cocaine? Let's say, yes? After 3 days, because some of you guys want to know about that stuff, right? Cocaine or marijuana. So what is the concentration of X after 3 days? If the half-life is 12 hours, and you injected, let's say injected, right? Or you smoked, not injected is better. You injected, let's say 300 milligrams of this business. Where's my video? Come see me after class. You falling asleep in my class. Did you have a rough night? You have a test today or something? Chicken still alive?
Yes.
I'm surprised.
Why?
It's really
I don't know.
big.
It's big, huh? Bring it one day to class so we can put it on the camera again.
Really?
Man, if that thing starts going, I'm gonna go crazy.
We're studying Thursday to bring it.
Oh man.
No, it's okay. So what is it, guys?
No, wait.
This is for today, you know. Patient doesn't have a lot of time. The patient is going to die on your hands. Hurry up. What do you mean what time is it? Can you look at the watch?
Too far back.
Well, you want to finish my class, all right? You got here late and you want to leave early. Hmm? You want to eat? What is it?
9.375.
How am I supposed to know? Do I look at a calculator to you? Okay, so this is how many days we have, yes? And let's say in the first 12 hours, what am I going to have? After the first 12 hours are over, yes? I'm going to have half of what I began. And it will be 300 divided by 2. How much is that? 150. I need to get to how many hours? That's kind of tough, right? 3 days of worth of hours is how many? First day is 23.9 something hours, 9.8, right?
You gotta divide it 6 times. Keep in mind.
Okay, wait, let's review. Let's review stuff because you guys don't know. How many days in a year?
365.
How many months in a year? 12. How many weeks in a month?
4. Except 2.
How many days in a week?
7.
How many hours in a day?
24.
How many minutes in a second?
60.
How many seconds in a minute? I don't think you have to do the calculation.
You all said 60 minutes in 1 second.
No.
Didn't that say it? I heard it.
No.
All right.
So.
The next 12 hours, this is the first day, yes? 24 hours. On the next 12 hours, we're going to have half of this, yes? Which will be?
75.
75, right? 75 milligrams. In the next 12 hours, what is it going to be?
37.5.
75 divided by 2, which is?
37.5.
37.5. Are we at 3 days yet?
No.
No. Another 12 hours. Oof, this is going to get lengthy, yes? In another 12 hours, it will be 35 divided by 2. How much is this?
18.75.
18.75. That's 2 days already, yes? Okay. And the next day is going to be 18.75 divided by 2. How much is it?
9.334.
What?
9.375.
Wow. We're going to have numbers up to here. And in the next 12 hours, at the end of those 12 hours, I am going to have this, right? Divided by 2. How much is it going to be?
4.675.
How much?
4.6875.
4.6, let's just say 4.7, yes? 4.7 milligrams. That's how much you're going to have after that many days. If I would have asked you after 50 days, would you do this 50 times?
No.
No. You would not do this 50 times. What you have to know is that this was 1/2, yes? Times another 1/2. You agree?
Yeah.
Because they're all of the same number, yes? So it was 1/2 times 1/2 times 1/2 times 1/2. How many 1/2s was that? 6 1/2s, yes? That is the amount of half-lives that occurred, yes or no? Or that elapsed. You agree? And instead of doing all that silly thing, we're just gonna say 1/2 raised to a power. Which power is that?
6.
Is the 6th power. And we're going to multiply this times the initial concentration we had at the beginning. So this number 6 here is the number of
Half-life.
half-lives. It is always 1/2, and then you just multiply by the concentration. If I want to find out how many half-lives into something else, it does not have to be a whole number. Yes, it could be a decimal place. So you need to convert this to the hours, same unit as you have here. 3 days is how many hours?
72 hours.
Sorry.
72 hours. That's all right. So 72 hours is the what? This is
It's the total time.
the total time, yes. Divided by 12 hours. And 12 hours is what? 12 hours is
The
half-life.
half-life time.
So what this gives you is the number of half-lives that have elapsed. How many was that in this case? It was 6. So how many times are you going to have this 1/2? 6 times. So if you multiply the concentration was 300, 1 divided by 2 to the 6th power. What's that equal to? Does that give you that number?
4.7, yeah.
Okay. 4.7. That's good. 4.7, and you use the same units that were given to you at the beginning. Let me give you the other 3 equations. Your homework is to memorize all the 6 equations by Thursday, yes? Cool. These are the half-life equation. T, 1/2. Now, does that T 1/2 tell you to get the time and divide it by 2? No. That T 1/2 means half-life. This is not a 2 you do anything with, okay? This is just a subscript indicating half-life, right? So this is half-life. And what's this? Half-life. And this is half-life. Do nothing with the 2. The half-life of the first number is 0.693 divided by K. The second half-life is going to have this on the bottom because it is 1 over A0, yes? A0 on the bottom. K is always going to be on the bottom. It was on the bottom here, and it will be where here? On the bottom. Where is it going to be for the third? Or for the 0th order? It will be still on the bottom. This A0, was it on the bottom here, yes or no? Still on the bottom there. That's it.
That's what I want to ask you.
Now this A0, where is it at? On the top. You're going to write it on the top here. But this is going to have a 2 on the bottom there because the concentration dropped by half. So it should
Where
have
does this 0.693 come from?
Is a ln of, let's say, 2 or half.
Okay.
Depends if it's minus or positive.
So would it be more accurate to write that?
No, it is not more accurate to write that. It is the same.
If you forget the number, you just do it.
Guys, is there a way for you to forget this number? The professor wrote this number on the board, and I was never able to forget it again. 0.69. 3 times. What's the deal? Hey, how can you forget the number?
And you got 3.
I mean, he wrote it, he didn't have to explain anything. I never forget, I never had to look at it again, to say the truth, ever again. Okay, that's it for today, my friends.